Thank you, everyone. So I'm Josh Gorton. I've been at Granicus about 4 to 5 years now. Prior to that, I was with a very large healthcare company where we built the world's largest healthcare data lake, which brought me over to Granicus. Wish we had Dremio then. So, Gaurav.
Hey, hi, everyone. My name is Gaurav Gupta. I am the CTO at NOAV. We are the implementation partner for Granicus. And my role in the Granicus is I'm acting as a data architect. And overall, I'm having 17 years of experience, primarily worked with Adobe for 14 years, built their large-scale CDP customer data platform, extensively used Snowflake, Databricks, and all those different products. Yep.
Thank you. So it's the only place I can think of where you talk about perfecting your iceberg reflections will get nods of respect and not sideways glances and concerned looks. That bomb. Thanks a lot, Perplexity. So big thanks to Dremio for having us out in this awesome Subsurface 2025 event in San Jose, and most of all for allowing us to share our story with you. So let's have some fun and get into the good stuff. We'll start with an overview of Granicus, who we are and what it is we do, look at the requirements for our analytics platform, talk about the zero-copy semantic architecture and data flow, then Gaurav is going to highlight some of the semantic layer optimizations we've done, our work with MCP, and agentic AI development, as well as citizen engagements, and we'll end with a not live demo. So what is Granicus and why should I care? Granicus empowers governments to connect, engage, and serve citizens by unifying data, streamlining communications, and delivering actionable insights through innovative cloud technology. We want to grow and truly understand your audiences because sending emails into the digital abyss is not worthwhile and time-consuming. Modernize service delivery, think fewer paper forms and more digital orchestration because it's 2025 and not 1995. Drive efficiency, compliance, and transparency. Make things more efficient, transparent, reliable. Because when processes are seamless, it benefits everyone and not just or staff and citizens alike. Next, government's 22 billion messages sent annually through Granicus. So if your inbox is full now, you can thank us. But the next time you see the notifications piling up, remember it's not you, it's us trying to keep you informed. Next, just like many of you, Granicus faced a puzzle of data fragmentation. Siloed data in a zero-copy architecture powered by Dremio intelligent semantic optimization. If you ever wanted to solve the multiple data set problem, this case study will show you how Granicus did just that. Thanks to innovative team and strategic partnership with NOAV and Dremio, we've transformed data completely into a competitive advantage, delivering real-time analytics and seamless reporting that our customers can use. Our main product is a Government Experience Cloud, a SaaS application. We'll start with Gov Delivery. This is our flagship product for digital outreach and communications. Powers government messages across email, SMS, and social media. Best of all, with every campaign, we give governments the analytics and spot trends, optimize communication, and measure results that matter. Next, Gov Meetings, also ranked #1. Streaming public meetings, agendas, and even video. Makes meetings less painful, though sadly doesn't make them any shorter. However, we can summarize them for you, so you don't have to watch the whole thing. Moving on to Gov Access, ranked #2. This delivers secure website content management hosting. Think of it as the backbone of government websites. And finally, Gov Records, ranked #4, secure digital processing and public access to official records such as land, vital, and court filings, because transparency matters. And let's be honest, nothing says excitement like digitizing government forms. So, and one thing to point out is each of these at one point was its own business or separate product that has come together. We can talk about that more in a bit. So let's talk about scale. Center is 500,000 government employees, keeping everything running smoothly from city budgets to lost dog posters. And at the top is $22 billion messages sent annually. That's billion with a B. If you printed out all those messages, your trees would file a 311 complaint, and I totally support them. On the left, 300 million subscribers. That's basically the population of the US plus everyone who signed up for and didn't click unsubscribe. 68 million forms submitted, and hopefully none of them have been faxed. 2.5 million community surveys completed. It's a lot of opinions, some helpful and some just creative. 200,000 hours of government meetings streamlined live. 2.5 million committee member resolutions. That's a lot of decisions. Basically the Olympics of who wants to support this proposal. On the right, 300,000 places where people might sign up as subscribers. We might just hold the record for the most number of clicks, so watch out, Taylor Swift. Bottom line, these numbers aren't just big, they show how Granicus powers real citizen engagement at scale. This is the requirements for our unified analytics platform. At the center, I do have to say it, the data mesh. But in the center is the accounts vault, contact vault, and external vault. So think of those as resolved entities, all being supported by the services on the outside. Think of that as a foundation for the secure, scalable data that we're sharing across Granicus. Surrounding it, outer data mesh are the systems and data sources, agency systems, third-party systems such as census data, entity enrichers, meetings management, 311, service requests, permits and licensing, surveys, communication, and web. They're all touch point where data originates. One thing, fun fact actually, the census actually has its own MCP server now. So that's how quickly government's moving. Top layer is the analytics platform. This is where the magic happens. Natural language processing for citizen requests, AI-driven recommendations for cohorts, dynamic dashboards, and self-service analytics for our data science teams. Let's face it, the AI dashboards are great, but there's always someone that will want the same report in Excel. And the real reason we need this is because without it, the data stays siloed, and silos are great for storing grain, but not data. And without it, insights are delayed, citizen experience suffers, and with it, agencies can unlock real-time analytics, improve decision-making, and drive better outcomes. All right, so this is what we wanted to get through. This is the masterpiece. So on the left are data sources. Granicus, we'll start with Granicus platform. Gaurav and I decided to start with these three data sets because we thought we could build a better citizen profile, so to speak. GovD, again, is a flagship product with a very simple retention policy of everything forever. It's a behemoth Oracle database. So we first tapped into that, thinking that this is all we need. This is going to be great. We can start to build what we need from here. However, the data wasn't that clean. The data we expected to be there wasn't always there. And there are certain pieces of data that just couldn't be tied back to anything else. So let's expand on that. We'll go next to EHQ, which is our survey product. We're essentially gauging citizen engagement and satisfaction. Like, how do you feel about public transportation? How do you feel about waste management in your city? The problem we found there is a lot of these surveys are people allowed to answer anonymously. So Gaurav's not going to tell me that he's complaining about my fence. He's not going to put his name down every time he fills out a survey. So that's a challenge there. Then finally, GXIF, which is our latest kind of product that gauges how people interact with the community and the government. This is a fairly new product. We didn't think it'd be that significant. However, given the data points that it had, it ended up being one of the most valuable pieces we have as far as building out these citizen entities. Next up, our enterprise system, Salesforce. Again, context issue. A customer is not a customer in GovD, it's a client. A customer is not a customer in EHQ, it's a site. And a customer is not a customer in GXIF, it's a customer ID. So we can't even stitch the customer ID across these products. There's no light customer ID. Salesforce has the Salesforce 18-digit ID, but you will not find that in any of the other products. GXA, that's our government experience agent. Think of it as a chatbot that will sit on city and government websites that allows you to interact with the data that's on there. It can answer questions from PDFs. What sets it apart, though, is it actually speaks government speak, so it's able to, similar to medical records, kind of interpret that government speak into something that you and I can understand. It also has pretty good guardrails on it, so it's only releasing the data that that agency wants the public to see. So it's not going to release any sensitive data or tell me how much Gaurav pays in taxes. Next one, compliance and government, that's host compliance. Host compliance is short-term rental compliance for cities, making sure anyone that owns a BRB actually has a short-term rental license for it and is paying appropriate taxes. Because even Airbnbs need rules. So let's get into the lakehouse. Start with the staging layer. I'd like to think of the staging layer as once you're made your connection to the data source, it's like a jigsaw puzzle. You're going to open it up, dump all the pieces on the floor, find your edges and corners, and figure out what you're working with. That's where we're going to create virtual data sets. We do zero duplication and allow direct S3 access. I consider this the folding laundry part of the data lakehouse. Next up is a business layer. This is where we're kind of unifying these entities, doing these cross data source joins. And what we have is customer 360, but we call it a citizen 360. And at this level, we're seeing 10 to 1,000 times faster response times. The application layer, so this is where everything gets prettied up. For our semantic insights, our KPI dashboards, reports, and metrics. And on the right are all the tools that consume it. We have visualization or BI tools, SimpleView, which is another company we bought. It's a BI tool with interactive dashboards. Our AI ML platform consists of SageMaker, Bedrock, some of those chat apps, and ML models. Graph database to start to, so we can build out these citizen profiles, and the data vaults that we had mentioned earlier. So key capabilities there, essentially just kind of the KPI dashboards again, the reporting, the dynamic reporting, enterprise scale, faster queries, and being able to not copy the data. Go ahead, Chris.
Yep. Sorry, one thing I just want to cover, like on the like if I go back to the previous slide. Sorry. Yep, just one thing I want to touch upon is like the thought process of using Dremio. So like when we started, I think me and Josh, we evaluated Starburst, if you've heard about it. It's based on Trino Query Engine, then Snowflake, Databricks. There are a lot of emerging products in the market. Then what's the choice? Why we went with Dremio? So just to give you a rationale is what we did is a couple of things. I pretty much come from like worked on Amazon. So Amazon has Athena. So it's behind the scene using Presto Query Engine. So we have a couple of things what we did. We first did the cost comparison between Dremio versus Starburst versus Snowflake and Databricks. Secondly comes that, as I think Josh already mentioned, that we have a lot of different acquisitions they did. And with the acquisitions, we are blindfolded, that we don't know how much data we are bringing in, right? And we don't want to copy the entire data set. So we wanted to clearly the choice is not a data lake or something, a data lake house. The choice is more aligned that if we can have something have zero copy kind of a system, wherein we can connect directly to the source. So immediately we restrict ourselves to the choice like Starburst and Dremio. And within Starburst, we did basically a query comparison between the Trino Query Engine versus the Dremio Query Engine. And we figured out that the Dremio was coming faster in terms of the data set we are having. And then finally, we reached to the conclusion that Dremio is something that we need to adopt for. So that was the thought process and the benchmarking we did. We spent a couple of months and then we finally reached to this conclusion. So that's the one part, the key part. The other part is, if you see the AI/ML part, I think everyone is talking about, and I think I asked the question about vector embeddings. So right now we are on V25 version, and the V25 version is pretty much like what we are doing is a Nessie data catalog. And for any of these cases, we are dumping that data into the S3 bucket and then basically dump into the, you can say OpenSearch, because we are heavy on AWS side. So we use OpenSearch for keeping into the vector embeddings. So that is how we are basically handling this part of the portion. The graph DB is interesting. What we are trying to do is we are trying to create our own native layer over the Dremio data. We are calling it like an entity resolution, because if you see, the data was coming from multiple sources, right? And as I think Josh mentioned, there is no unique ID, like how we stitch the data together. So that kind of a framework we are putting on the top of the Dremio. And that is what we are calling as an entity resolution. It's a custom solution that we are building over top of Dremio that is there. Just want to touch upon those things. Now quickly come to the data flow. I think pretty much the data flow is very standard in Dremio right now. We initially bring the data, and I will give you a short demo in the end. We get the data, we connect to the data source, then we basically build what we call as a staging layer. In the staging layer, we typically do some modification. For example, you want to change a column name from A to B, or you want to combine multiple columns into a single column. So very basic one. Then the business layer is the one actually where we do a lot of joins and those kind of things, the reflections and everything. And the application layer is the one where we actually drive all the semantic layer, the metrics. And that is where we connect all the dashboard and we pull all the metrics along. And that is why there is a key difference when I talk about the next slide, how you do the optimizations along the reflections. Now coming toward the semantic layer optimizations. So typically what we are trying to do, and remember we are on V25, so we don't have automatic reflection feature yet, right? So we are still doing the manual process of reflection optimizations. So typically in Dremio, you have three kind of a different reflection layer. One is called raw reflections, where you basically have wanted to do and cache the data, which is the raw data. That is called raw reflections. And then you can do aggregated reflections. So for example, you want some operation or a count operation or average or min, max. These are some of the aggregated function in the SQL world. So let's say you want to do those kind of saving, those kind of query savings, that is called aggregated reflections. And then you can do external reflections. Means you have the external tables in Iceberg and you wanted to do those reflections. So since we are on V25 and we have a different data sources, like some are in millions of records contributing to petabytes of data, and some are very small, even in KBs we can define, and few records. So the idea is that what we're doing right now is we are doing a manual reflection optimizations. We review each of the data source, we move the application layer, we understand that if this query is taking time, should we do the raw reflection or aggregated reflection? And even look, reflection in my sense is actually copying your data from the source, right? It's a kind of a copying operation. So we need to be very sensitive that what reflections we are building. It's not like we can build a reflection for everything. Then we are defeating the purpose of a data mesh itself, right? So that is what kind of an optimizations we did. And finally, we are able to run for millions of records we are getting in few seconds. That's kind of optimization we have reached into. And it's not just a reflections optimizations, we did table structure optimizations, partitioning strategies, for example, how we are getting the data from the source system itself. All of this goes into making sure that the reflections work within the seconds of durations. Now, interestingly, what we are trying to do is, we are again on V25. There is no semantic search feature right now. But what we are trying to do is, and soon I think in a couple of months or maybe a month, we will move to V26. But right now what we are trying to do is, we are building and we did a POC with the Dremio MCP. So we took Dremio Open MCP, open source MCP, which you are having, and we built and tried to use a Claude client because the Claude can maintain the conversational history. And what we did is, because there is no concept of semantic search right now, so we, for each of the data source, we build a data dictionary, which is nothing but a wiki documentation. Now that wiki documentation sits very close to the data itself within the Dremio atmosphere or Dremio environment. Now, whenever we fire a query from a Claude client using the Dremio MCP, it basically goes onto the source, understand the schema because the data dictionary is already there, understand and make sure that whether you need a data from an application or a business or a staging layer, what kind of data you want, what kind of view you want to access, all of that is basically documented in a data dictionary. So we are making sure that the data that is retrieved is of an accurate precision. That is how we are managing this layer as of now. But we are anticipating that when we move to V26, probably our life will become easy. But as of now, we are doing this. For agent thing, what we did is we are using LangGraph for now. It's an open source framework. So we connected, we created a multiple agent system like you can see on the left. There is a query agent, and then there is a discovery agent, analytics agent. So we built a multi-agent orchestration using LangGraph, and then we connected to the Dremio MCP, which was running on a Claude client. So that is how we have built the entire system as of now. And we did this POC. I would not say this is a fully baked product. Earlier version, we already have millions of records there, but for this is like still a POC, I would call it like. And once we move to V26, then we probably try the bigger version. This is just a screenshot, and probably you will see the demo after this one. But just to give you a screenshot, if you look at, this is the citizen engagement matrix. You can see the gender, you can see the ethnicity, the birth date. I'm not exposing all the data. It's a very sensitive data. It's a PII data, highly regulated data. So we do a lot of anonymization also within Dremio itself, making sure that the data is not natively being viewed, right? So that's why I've hidden most of the PII kind of information here, but you can see this is a citizen engagement matrix we are getting. And as Josh mentioned, like we are getting the email clicks. For example, we send email, you click on the email, all of those information is with us. Yeah, that is all I just want to cover. I wanted to give you a quick demo, just a 2 minutes demo, which will give you a quick preview that how we actually build up this entire system. And it's live right now in production.
So just to interject real quick, Gaurav. So Gaurav touched on something important, which is one of the very first things we do once a data engineer gets access is create the data glossary, data dictionary. That's priceless. Without that, we wouldn't be able to do anything that we have. So that's very important as we kind of start down this path.
Yeah, and right now it's a manual process. Obviously, we want to use AI to do that as well. For example, the schema discovery and all. But right now it's a manual process. But for my understanding, working for almost 17 years in the industry, I think the AI can mature, but they cannot rule out the humans from the loop. So the idea here is like, data dictionary that we built right from the source till the staging business application layer, right? So it's highly accurate. So whenever you're firing an NLP query, we are getting the accurate results back. We have tested the performance, we have tested the accuracy, and that is what we are basically working upon because the accuracy and the performance both are critical for us.
Right.
Yeah.
And at the end of that process, we assign a data steward too. So we actually have a SME.
Exactly. So we have also the process implementation. For example, for each of the data source, we have a data steward kind of an environment. So data steward role is to make sure the data dictionary is in place. It makes sure that all the data is clean up. It makes sure that there is nothing like a PII which goes and exposed directly. All of that is as the process we are implementing. So along with the product, it's the process is also playing a critical role here. That's the main part. Yeah. So I want to just give a quick overview. So here you can see like all the databases, for example, and pretty much we are covering 40 different data sources. And we are covering Oracle, MySQL, you name it, PostgreSQL. I think we have not left anything. We are covering all the databases. Then in terms of the object storage, again everything like S3, ADLS, Salesforce data goes into ADLS. So we are covering pretty much every data, you can say object storage here. And then these are the data sources you can see. Like this is a QC environment, this is not a prod. So you will see very less sources here, but it will give you a quick preview. So now I will go more deep into GXIF. So you can see like we created the staging layer and the business layer and then finally the application layer. Now I go more deep into application layer. You can see that we have the demographic count, demographic details, email verified users, user data. So we created all of these. Let me go into one of these. So if you run this particular query, it's a simple query, but we have run the complex joins queries. It's pretty fast what we have done. We have to optimize all the reflections. And you can see this query runs here. You can see all, again, the same data which was there in that screenshot. You can see the ethnicity, the gender, the zip code. Now let me see, like lineage is very important from the governance perspective. So you can see that we have now the application layer. If I click on business, you can see the data is coming from the Microsoft SQL, right? So that kind of governance, we want a lineage is a very important feature for us to backtrack it. And that is how we build the application layer. You can track every details. Now coming back for the reflections, this might not be the exact example for reflection. This is on a QC environment, but we created a raw reflection. You can see the history. It's showing less than 1 second here, but believe me, the same data with a huge data on the prod is also taking less than 1 second. So that kind of optimizations we have reached with that kind of huge data set. And that is what we are trying to do. We are doing all the reflections manual tuning right now, but yeah, I'm hoping that going forward, and this is the wiki. Sorry, that's a quick glimpse, but that was the wiki that we created, making sure that we are able to do the semantic search without even moving to V26 version. Yeah. So yeah, I think that is pretty much from our side today. I think
so.
Yeah, that is from our side overall. Yeah.